So let's try to discuss about um, the requirements that has been provided as part of this competition here. These are the list of mandatory steps that needs to be done as part of the requirement of this competition. They say the application flow must include, we need to have one cleaning of the bad data. It says ignore the data which has landfill value which is not 0 or 1, and it would like to enrich our data with the IP to geomapping lookup. And it says calculating the cumulative count of number of anomalies detected. It says like triggering an alert for every anomaly detected. It says like triggering a critical alert if the 20 anomalies have been detected in 1 minute. It says like persistent every incoming record into Elasticsearch, persistent every anomaly that is detected into RabbitMQ, and then it has identified the two visualizations. So what are the basic components that are needed currently? We need the message, and then we need to ensure that we have the field which can take the latitude and longitude geomappings, and also we need to check that these two alerts have been configured. So let's go back and see if they are available or not. So I'm going to a message configuration. I'm going to use this network connection details. Let's try to look at the network connection details. And let's wait. It's slow here. There you go. Let's go to the field connection. So you can see all these fields just map to the fields of our input coming data set. And then we do have this extra field called as geopoint, and you can clearly see it's an input for field. It doesn't come as part of input data set. We need to set it. So we have a field ready in the message which can take the geopoint value. So I'm going to cancel it. And then let's go to the alerts page. If you can take, they say like create a general alert for every anomaly detected, and then it says create trigger a critical alert if there are more than 20 anomalies detected within a 1 minute. So let's go back into the alert section. Let's go to this configuration. I'm selecting my network connection details message. So I have configured two alerts, one called as an anomaly alert and one called a critical alert. So let's try to take a look at this anomaly alert. How does it look like? So this name is anomaly alert. As I said, it's a general alert, and the condition which you're trying to look at is if anomaly output column is equal to true value. So it's if it's a true, and then this is a message we are telling anomaly has been detected from particular IP address. So when you provide the specific syntax over here, it tries to print the IP address from which the anomaly has been detected. And then let's try to look at the critical anomaly that has been said here. So it says like critical anomaly if more than 20 anomalies detected. So take a look at the configuration here. So it's a critical anomaly. The type goes to critical, and as you have to aggregate, the aggregation has been enabled. And then if it's like 20 times, and with the 1 minute, you need to put 60 seconds over here. So the criteria is again remains the same. Anomaly output column equals to true, and then the message is more than 20 anomalies have been detected in 1 minute. Okay, so we could configure both anomaly configurations, and let's try to go to the pipeline now. So the component of the geo point is available. The component required for both anomalies have been already been configured. So I'm going to the data pipeline section, and then this is the pipeline which I have already configured as part of the requirement. So let's try to take a look at the pipeline over here. So we have two incoming data sets. These are the data generators pulled out from the channel section. So it has the train data set, and then you see training underscore sample dot csv, and it next one is you see prediction underscore sample dot csv, and then the next immediate step which says like cleaning the bad data, ignore bad data if the landfill value is not 0 or 1. So there is a land filter over here which filters land, which accepts if the land value is only 0 or 1. And then it, there is another land filter for prediction data set. Again, it accepts the value of 0 or 1. You can see the R has been selected over here. And then if you go to the next step here, it says that enrichment of the data with latitude and longitude value using an IP HBase table. So you can see the train geo enrich. So I'm setting the geo point value using the lookup HBase function provided. So lookup underscore HBase is the function, IP to geo is the table, and then IP, this network connection message dot IP address is the input value provided. So geo point is a column family, and then geo coordinates is a column value which you're trying to get and assign it to the geo point. In the same way, you could see the test geo enrich for the incoming prediction data set. This is called as test geo enrich. Ideally, I should have named it as a prediction. And then we are trying to pass it to a streaming k-means model. So if you go to a stream, this is a streaming k-means model as part of the available stream analytics models, Spark MLlib. So I'm using this model for both training and prediction. So the message name would be network connections. The training component would be train geo enrich, and prediction component would be test geo enrich. These are the ones that you went the previous step elements of your canvas. The decay factor is 1. I would like to select 1 because I would like to provide the fresh data the more importance than the old data. So as the major purpose here is to detect anomalies. The data anomaly has been detected. The threshold value would be 2, so that for any incoming data set, if the distance of the point from its closest centroid is greater than 2, I would like to select that point as an anomaly. So the anomaly output will be stored in a field called as anomaly output column, which will contain either true or false value. And if you go to the variable type, these are the list of input variables that have been selected for the model creation. And previous video I have clearly shown from the dendrogram, I would like to select for 6 random clusters. Yeah, if you don't want to create a random clusters, you can always create a k-means clustering and then export the values using a PMML file. So how does that look like? I can show you an example, but I would like to go for a random clusters because I'm trying to use the both training dataset and prediction dataset parallelly. If you would like to provide the cluster values yourself, you can always remove this random thing here, and then you can enter the cluster values. Or else, so these are the cluster output value, cluster center variable, transformed feature variable, and then this is the distance field. Okay, so if you want to enter the k-means, this is how it looks like. Um, so if you can export your k-means model in a PMML format, this initially when you export from R, latest value of R, it's only for it will give you the 4.3 PML version, but currently Stream Analytics supports only 4.2, so you'll have to modify this. The support team of Stream Analytics was able to identify this and help me out. So if you see, these are the different variables for different clusters, from the cluster name 1 to cluster name 6. You can enter these weights over here in case you don't want these weights to be randomly calculated on the fly from the streaming data. But I am going with an option about random clusters and then variables to be assigned. And then output of the cluster variable, you could see there are 2 alerts. One is anomaly alert and critical anomaly alert. And then we would like to filter an anomaly value here. So if anomaly value is equal to true, and then you could see all the incoming data is going into the Elasticsearch with a NS209 as a field. And then you could see all the anomalies are going into RabbitMQ with anomaly Q1, anomaly exchange 1, anomaly key 1 values over here. We are saying all the fields over here. And then as part of this requirement, these two has already been persistence requirements have already been satisfied using Elasticsearch and then RabbitMQ in the canvas. There's like cumulative count of anomalies and then anomaly plotted over time series line chart. So to satisfy these two visualization requirement, you'll have to pull out this cumulative aggregation processor, and then you can see I'm counting the number of anomalies, I'm adding current timestamp, and the anomaly would be stored into anomaly count field. So this is the entire design of the pipeline. So I would like to leave this and then execute the pipeline. So we'll have to wait until the pipeline runs. I would like to show the previous run results which I was in during my testing phase. So here it goes. So this is one of the plot of the requirement which was mentioned over here, like anomaly as a time series line chart. So which would like to we'll see now currently, and then the other screenshot is anomaly count. So this is a line chart, and probably this one, yeah. So nothing on x-axis, anomaly count, cumulative anomaly count as a line chart over here, as a counter plot. So let's try to see. I would like to submit these two screenshots as the initial requirement. Let's try to see if the pipeline has an error. Oh, not sure why the pipeline is active now. Oh, I don't know why was there an error, really. So again an error. Let me correct what's went wrong and then come back on it.